In this Part 1, Introduction, we will first cover about the definition of material flow cost accounting. Secondly, we will explore the 4 types of associated costs regarding material losses. Third, we will go back into the past when the MFCA was first established and the history making currently took place in these MFCA implementation. Finally, we will explain briefly the ISO standard applied in MFCA methodology. Let's have a trivia here. What do you have in mind when we talk about material flow cost accounting?
An accounting thingy?
Oh, bolila.
It must be cost related, right?
Yes, it is.
Is it about recycling of material?
Unfortunately, it is not. Material flow cost accounting is not about waste recycling, since recycling also adds more cost in it.
Okay, so, what it has to do with environment? It doesn't look connected though.
Oh no!
Alright, let's learn what MFCA is. Based from ISO 14051 to 2011's definition, material flow cost accounting is a tool for quantifying the flows and stocks of materials in processes or production lines in both physical and monetary units. This MFCA develops because many organizations are coming under increasing pressure to minimize the environmental impact of their activities, as well as optimizing resource consumption to enhance the company's cash flow. It is a management tool used by manufacturing companies to improve the efficiency of their inputs in order to save energy and costs by avoiding material losses, which we commonly refer as waste. MFCA is applicable to all industries of any type and scale that uses materials and energy, regardless of their products, services, size, structure, location, and existing environmental management systems. In nearly all cases, MFCA has proved to be an effective decision-making tool in making effective resource and cost savings for its adoptees. MFCA is one of the major tools of environmental management accounting, EMA. By definition, EMA focus on identification, collection, analysis and use of energy, material and environment-related physical and monetary information for internal decision-making. Going deeper, MFCA also aim to simultaneously reduce both environmental impact and costs. These tools were developed in recognition that environmental costs were often left out of conventional management accounting techniques. Thus, MFCA will reduce the adverse environmental impacts and associated costs. This MFCA method specifically focuses on avoiding material losses incurred during production. Material losses include air emissions, wastewater and solid waste. By avoiding these material losses, energy, costs and CO2 emissions can be saved. Even if the loss of material can be reworked, reused internally or sold later as recyclable material, the loss in value will probably be higher than expected. Hence, MFCA aims to avoid losses in the first place instead of just recycling them. Besides that, MFCA have provided a way to illustrate how improving environmental performance can also improve a company's bottom line. Thus, MFCA is considered to be an effective approach for the manufacturers and other businesses to achieve higher productivity. Material losses can be reduced and efficiency of material and energy usage can be improved. In classic cost accounting, these material losses are budgeted as waste or disposal costs in a very general manner, leading to ill-informed or poor decision-making, with both environmental and economic consequences. However, once available via MFCA, all costs that were incurred in the process chain before the material input became a material loss are considered. These data are the hidden costs. 4 types of the hidden costs associated with the wasted materials are material, energy, system and waste management costs. Material costs are the expenses for the materials that are used or consumed in the production process. Energy costs refer to cost for energy used to enable the operation. For example, electricity, fuels, steam, heat, and compressed air that is not incorporated into intended products. Meanwhile, system costs refers to other costs incurred in the course of in-house handling of the material flows, for example, cost of labor, cost of depreciation and maintenance, and cost of transport. On the other hand, Waste management cost is the cost of handling material losses generated in a production process. It includes the costs for on-site waste management such as the treatment of wastewater as well as costs for outsourced activities, for example the waste recycling or disposal. As a result, the sum of all costs attributable to material loss can be obtained. This material loss cost is equal to the maximum cost savings that can be obtained in a theoretically optimal state in which there are no material losses. By using this method, a true costing of material losses that includes a significantly wider range of factors is achieved. How does this MFCA work in practice? In its most simple form, MFCA works on the principles of mass or material balance. The flow and stocks of materials during production are traced and measured in physical units such as mass or volume. Let's first imagine it applied in a single process in a t-shirt production line. If we put 100 kilograms of cotton as input into our processing unit, and we got 60 kilograms of t-shirts out, we know that we've lost 40 kilograms of material in the manufacturing process. This is what we call material loss. The next step is then to evaluate monetary values associated with those material lost. The 4 types of associated costs mentioned before are also quantified. These are assigned to the products and material losses based on the proportion of the inputs that flow into each. In this example, if the cotton input cost $100, we might conclude that we had an economic material loss of $40, since 40% of our material was wasted. We would also have to add our energy costs, system costs and additional waste management costs to handle our unused cotton. In doing this analysis, an organization can not only see their resource losses, with its resultant environmental impact, but also be able to see where it's losing out economically in its production processes. How to figure out these costs? MFCA provides a fundamental tool for measuring and better understanding resource usage, the material flow model. This model is always the initial step to be set up and validated when using MFCA for a production line or an entire site. As the common saying goes, you can't manage what you can't measure. It is developed to guide MFCA to increase its transparency of material and energy use practices during the production processes, as well as with the waste streams and material losses. So, once it has been developed, costs can also be assigned to the waste, material, energy losses and emissions which occur throughout the full value chain. Therefore, it helps in avoiding non-essential material and energy flows within the production processes. This data can be used to seek opportunities to reduce material use and material losses, improve efficient uses of material and energy, and reduce adverse environmental impacts and associated costs. Therefore, by calculating the real costs of material loss, it dramatically increases the potential for optimization. The manufacturers not only increase energy and resource efficiency, but also reap the benefit of cost reduction. This allows organizations to more effectively understand and target the areas in which they can make the greatest savings. This is an example of material flow model, conducted by a Japanese company named Sekisui Chemical Company Limited. Sekisui Chemical manufacture a variety of chemical products in its 34 sites all over Japan. In particular, this model highlights the comparison of costs associated with products and costs associated with material losses. Any costs that are generated by and associated with the flows and stocks of materials for each process are subsequently traced and quantified. Then, the costs associated with those material flows are evaluated and analyzed. Therefore, from the material flow model illustrated, we can see that the total material losses in every material flow in this company was 190 million yen. Let's have a look at the history of MFCA. The idea of material flow cost accounting was originated in the 1990s in Germany. The aim was to develop an instrument to support environmental management and eco-controlling. Despite being developed in Germany, MFCA has gained largest traction throughout the Asia-Pacific region, but most prominently in Japan. Since it was introduced in Japan in year 2000, until year 2011, more than 300 Japanese companies use the MFCA. In fact, starting from 2006, A special annual award for MFCA was given by Japan's government to recognize companies' achievements in gaining successful results when applying MFCA. In 2011, the ISO Technical Committee developed a standard accounting protocol, ISO 14051, in order to standardize the MFCA methodology. Then, the breakthrough came in Japan. One example is the camera manufacturer Canon, which was able to save more than €30 million in material costs between 2004 and 2012 through MFCA. Initially, MFCA is designed for use within a single manufacturing company. Nowadays, the MFCA impact is expanding to the upstream and downstream of supply chain that involves multiple organizations. In this way, MFCA can help a larger number of suppliers and firms to develop an integrated approach to optimize full chain resource efficiency as well as act as a driver for company collaboration. Being recognized as key approach for sustainability, MFCA was internationally standardized to be ISO 14051 in September 2011. This standard accounting protocol is developed by the ISO Technical Committee of Environmental Management. The ISO 14051, 2011 protocol falls within the broader ISO 14000 family of standards for environmental management accounting. The ISO 14000 family also includes standards for the other most prominent sustainability measurement tools, which is the Life Cycle Assessment, LCA, standards, ISO 14040 and 14044. The MFCA framework presented in ISO 14051-2011 includes common terminologies, objective and principles, fundamental elements, and implementation steps. However, detailed calculation procedures or information on techniques for improving material or energy efficiency are outside the scope of ISO 14051-2011. External costs are also excluded from the scope, although an organization can choose to include external costs in an MFCA analysis.